Hello everybody, my name is Sulabh Adhikari and today I am going to present on Euclid proposition 5, and this proposition states that in an isosceles triangle the angle at the bases are equal. So I am going to present on this topic, so let's get started. At the very first we are given a triangle ABC, and triangle ABC is an isosceles triangle with the base BC. This is the given thing, we are already given with that thing, and we have to prove that the base angle of an isosceles triangle are equal. As we know, the triangle ABC is an isosceles triangle. We know AB and AC are gonna be equal because the two sides of an isosceles triangle would be equal. And the thing we need to prove is angle ABC is equals to angle ACB. So angle B and angle C should be equal. Those are the base angle of an isosceles triangle. So to do this, we need to do a small construction. First of all, we will draw a line AD from vertex A to the point D, which would be the midpoint of BC. That would make like BD and DC would be equal. So which will help us to prove this statement. And let's get started to the proof. First of all, AB and AC is equal. That is the given thing because it's an isosceles triangle, and BD and DC is also equal, as D is the midpoint of BC, so BD and DC is equal, and AD is the common side in both of the triangle. So we are taking triangle ABD and ADC. So when we take these two triangles, it is going to be congruent by SSS axiom. So that's side axiom. We prove that these both triangles are congruent to each other, and now we know the corresponding angle of congruent triangles are equal. So angle ABD is equals to angle ACD. Since D lies on BC, angle ABD is equals to angle ABC, and angle ACD is equals to angle ACD. Okay, this is all the proof about the proposition 5. We can prove this very easily, and this is very easy proof. We'll go for the application, real world application of this proposition. For the real world application, I have separated the three application. I like to go with the use of proposition 5. The equal base angle of an isosceles triangle helps to create the balance, symmetry and stability in many real life world structures. So it helps in engineering and architecture world, not only in like geometry. So number one is roof trusses. Many roofs use triangular trusses design that forms isosceles triangle because the two sides of an isosceles triangle are equal, and the base angle are also equal. This helps the symmetry help distribute the weight evenly across the roof. So in the both sides the weight is going to be evenly distributed, and it make the foundation more stronger and stable. So this one is the first application and use of proposition 5 in the real world. For the second one, I have cable style bridge. We all have seen like cable style bridge, and it is also used by proposition 5. Many bridges use triangular support system that resemble isosceles triangle, as the equal basis helps balance the force acting on the bridge. The forces acting on the both sides of bridge are balanced because it is made by the proposition 5 and worked on like the isosceles triangle basis equal theorem. The balanced design improve the structural strength, and allow the bridge to support heavy loads safely. And lastly, we have the application 3, which is for the sailboats. Sailboats are often safe like isosceles triangle because the base angle are equal. The sail maintains symmetry. This helps the sail catch the wind and efficiently, and improve the boat's movement through the water. So whenever the wind comes, it will exert the pressure on both sides of the bases, so it will evenly distribute and like make the movement of the boat more smoother and accurate. Okay, so for the conclusion, I would like to say, like, in all of the three examples, we see an isosceles triangle being used in real world design. According to the Euclid proposition 5, the base angle of an isosceles triangle are equal, so that it helps to create a balance, symmetry, and stable in many real life world structures. These equal angles contribute to balance, symmetry, and stability, making the proposition useful not only in geometry but in the architecture and engineering. And by saying this much, I'd like to thank everybody for listening.